A pleasant day to everyone. For today, allow us to present our proposal in line with the project of a brighter future. I am Ralph Richmond de la Cruz, together with
Si Jen de Balocos.
Mercy Grace Manalo.
Kami Bendicio.
Emmanuel Daniel Estrada.
And Anthony Gases.
and we are the Sci Vision, a youth-led group that centers on developing science ventures, particularly on providing sustainable and adequate electricity to the public. To begin with the proposal's rationale, let us have Mr. Emmanuel Estrada.
Thank you, Ralph. The group actually decided to choose 4 locations, and one that would fit the most from our project is the barangay Tita and its province, Zamboanga del Sur. The barangay faces a severe problem with its electricity sources for its households, and the group found out that the barangay as a whole does not have stable electricity. This is why the group decided to develop a floating solar panel generator as their primary generator for the area. Now, for our objectives, let us welcome Ms. Cesare de Balojos.
Thank you, Mr. Estrada. For our SMART objectives, Vision aims to provide sufficient electricity in Barangay Dita, Zamboanga City through a floating solar panel generator to accommodate at least 40 households that consume an approximate 1.854 kilowatt hour. In achieving this, we ensure to provide best quality materials for the sustainability and efficiency of this floating solar panel generator that will meet the 7 SDGs by the first quarter of 2025. Next is for our short-term goal. By 2025, Vision hopes to build 24 solar panels that will provide electricity to at least 40 households in Barangay Dita, Zamboanga City. And finally, for our long-term goal, by 2030, Vision hopes to have installed at least 100 solar panels to meet the energy needs of the entire Barangay Dita in Zamboanga City. Next to present the survey application, let's have Mr. Estrada.
Now, as you can see on the picture, the one with the white circle is the Barangay Dita, and its proximity extends up to the water refilling station and the Bugyas Island. For the next picture, you can see an example on where we can use the floating solar panel. Also, in the other picture of the Bahay Kubos, as seen, the people that lives in the community are really in need of a stable electricity. Now, for our electricity requirement, let us welcome Ms. Chelsea Danolo.
Thank you, Eman. Electricity consumption or requirement serve as an important measure of a specific place electric power development. Considering the situation of each household, we have asked them to list the common appliances that they use and its power consumption. In order for us to know the total amount of energy used by a household, first we have list the number of watts for each appliances. Next, we have set an estimation for the average number of hours upon using the appliances. Following that, the energy consumption formula is used on each appliances to obtain the kilowatt hour or the energy consumed, garnering a total of 1.854 kilowatt hours in one household. Every appliance in a household contributes to total energy consumption. Next, we have Anthony Gases to discuss the generator system.
So a solar panel are a type of generator that absorbs the sunlight and converts it into electricity. The solar panel can also be defined as a photovoltaic module and consists of photovoltaic cells. The process begins by absorbing the photons from the sun and converting it to DC or direct current. And this DC will be transformed to AC or alternating current by the system inverter. Thus, the AC will be the one utilized by the household. The floating solar panel consists of solar panels that are floating in the water. The floating solar panel must be a light structure for it to be able to stay above the water surface. This is connected to a central inverter that will be transmitted towards the transformer and the transmission lines. And these are the advantages of using the floating solar panel generator. Encourage the land use efficiency, higher generation and performance, easy installation and uninstallation, saves water resources through water evaporation, and highly advanced and offers further modernization. The challenges of using it are intricate maintenance of the system, changes in weather condition, and cost of installation. For the cost of materials, let's have Kim Allen Indicio.
Thank you. And now, as for the cost of materials of our project, first would be the floating system, in which will consist of a total amount of 490,000 pesos. Second would be the 360-watt solar that would have a total amount of 318,524 pesos, in which will cost of a total amount of 13,272 pesos per piece, and would have a total number of 24 pieces for this project. Next would be the mooring lines that will cost a total amount of 4,500 pesos. And this material is actually the connector or the cable for connecting the floater and anchor. Next would be the anchoring that will cost a total amount of 14,400 pesos, and the central inverters will cost a total amount of 110,826 pesos. Lastly would be the miscellaneous materials or the extra materials, in which will cost a total amount of 25,000 pesos, and the overall total cost would have a total amount of 963,254 pesos for the completion of the project. Next, to discuss the next part of the presentation, let us have Mr. Ralph De La Cruz for the next part of the presentation.
For the implementation of the generator, as seen on the screen, is the aerial view of the generator system. The yellow circle represents the area where the floating solar power generator will be situated. This is where the primary materials of the generator, such as the solar panels and inverter, will be placed. Next, the broken lines represents the cables that will run from the generator itself towards the nearest available transmission tower in the area. Finally, the red circle represents the area that will receive electricity in the barangay DITA. As aforementioned, the group will just cater at least 40 households for this initial project. Thus, it will just be an specific area nearest to the generator system. Next, shown in the screen is an example of the floating solar power generator when placed in the area itself. Now here is a more comprehensive explanation on how the entire generator works. First, the significant parts of this that are vital in the proposal are the solar panels, floaters, mooring lines, anchoring system, inverter, and transmission tower. As the solar panels receive sunlight, it will then be transmitted through the cables towards the central inverter that will transform a DC to AC. Then the AC will be transmitted towards the transmission tower that will be responsible for its distribution on the different households. Next, for the generator calculations, let us start first by identifying the kilowatt hour that a solar panel can produce. Here, we multiply 360 watts times 10 hours, which is the estimated time of sunlight divided by 1,000, thus having 3.6 kilowatt hour. This represents the kilowatt hour for one solar panel. After identifying the kilowatt hour for one solar panel, let us now identify for the entire solar panel system. Here, we just simply multiply 3.6 kilowatt hour to 24, which is the number of solar panels to be used in this proposal. Then, we have an answer of 86.4 kilowatt hour. This is the total kilowatt hour that can be produced by the entire solar panel system. Next, let us identify how many households can 86.4 kilowatt hour cater. So here we divide 86.4 kilowatt hour to 1.854 kilowatt hour. 1.854 represents the energy consumption that were presented earlier. Thus, having a total value of 46.60 or 47 households that spend a minimum of 1.854 kilowatt hour can receive electricity from the solar panel generator. Next, to present the overall findings of this proposal, let us have Ms. Chelsea Denoyo.
Now that our presentation has nearly reached its end, we, the Vision, envisions a bright future with our presented overall findings of our proposal. The proposed plan can attain its primary objective of providing the electricity to at least 40 households of Barangay Dita. Under 10-hour sunlight, one solar panel can generate 3.6 kilowatt-hour and 24 solar panels can generate 86 kilowatt-hour. The proposed plan can supply electricity to 47 households, and for future analysis and aligned with the Vision's long-term goal of electricity for the entire Barangay Dita, 103 solar panels are needed to meet the electricity demands of 200 households. And that brings us to the end. We, the Vision, would like to thank you for your time and attention today. We sincerely appreciate that we're given this opportunity to present to you all. Now, we would now be interested to hear from you with your thoughts or questions.